today we are just going to do examples. I don't want to give you any more theory today. We'll save theory for Friday, and we're going to move on into some more stuff. Today, we're just going to be looking at chapter 4, section 5. And we're just going to do some of the exercises from chapter 4, section 5. And yeah, so let's just plug along. So basically, these are all applications of systems of equations. And I think it's good to see how they're going to show up in tests and quizzes that you're going to see, especially like standardized tests and stuff like that, so that you're not just flapping in the wind when you see them. But also because it's good to see these kinds of questions to, like I said before, like if you could see how such questions can be solved using a system, you could save yourself a lot of heartache, especially like if you're in, say, a chemistry class and you're like, man, this is a tough problem. And the way that your teacher has taught you to solve it is this really convoluted way where you're setting a bunch of crazy equations equal to each other and wasting time. If you could identify like, hey, I've seen this before. This is a lot like, in fact, I could turn this into a system of equations. And I know easy how to solve a system because Justin made me do 1,000 of these matrices. So by this point, I'm good to go. So I think it's good to go over these applications. So we are in. So I'm not going to write the full word problem out for each one of these, but it's all stuff from chapter 4, section 5. And the first one I want to do is number 4. So number 4. Okay, it says the sum of 3 numbers is 26. Twice the first minus the second is 2 less than the third. Already I'm getting a headache. The third is the second minus 3 times the first. Find the numbers. Okay, do you have your book with you? Can you? Okay, awesome. Okay. And so do you see that problem that I'm talking about right now and you can follow along with it?
Yes.
Okay, cool. So, okay. First thing that goes through my head is, okay, 3 numbers, right? So there are 3 unknown numbers. I have 3 unknowns. Let's give those numbers names. What names would you like to give to those numbers?
X, Y, and Z.
How about X, Y, and Z, right? Okay, so I'm thinking, okay, we have 3 numbers, X, Y, and Z that I need to find. So immediately what's going on in my head is something like this. I'm thinking, and this is a general principle, I have 3 unknowns. That means I need how many equations?
3.
3 equations. Okay, so that's what's going on in my head. I'm thinking, wait a minute, I have 3 unknowns. I have to find 3 equations. And in some of these questions, it's obvious what 3 equations they're giving you. Some of them it's not, and you have to go, oh, wait a minute, I need a third equation or whatever the context happens to be. But I know that I need to find the 3 numbers. And so I'm thinking the whole time, okay, I had better find 3 equations. So it says the sum of 3 numbers is 26. Is that an equation? What is the equation? How could we write that?
X plus Y plus C equals 26.
There you go, right? Okay, so 1 equation is done. Check. Okay, now, twice the first minus this. So I'm already thinking, okay, I need to make sure that we're on the same page here. We're going to call X the first. We're going to call Y the second. And we're going to call Z the third. Now, starting off, I could have done that in any order I wanted. But now once I've made that decision, I've got to stick with it. And so this is going through my head right now too. Like, all right, whenever they refer to the first, they're talking about X. Whenever they refer to, and so on and so on. So it says twice the first minus the second. How could I write that? What does that mean? Twice the first minus the second.
2x minus y.
2x minus y, twice the first, take 2 times the first, minus the second, and it said it is 2 less than the third. So what do I do now? I have 2x minus y, and it's supposed to be 2 less than the third. Yeah, this is why I want to go over this, because when I read that, I also go, wait, what? Okay, so let's think about this. It says twice the first. Okay, so 2x minus y. So that quantity is 2 less than the third. So I'm thinking that quantity is equal to something. So it goes through my head. It says that this right here is 2 less than the third. So in other words, if I took the third number,
Z minus 2.
Z minus 2. And now once I do that, I always double check it, because I think, because I'm always worried that I put the minus 2 on the wrong side, right? But now I'm going to just kind of step back and say, wait a second. Okay, does this make sense? Twice the first minus the second is some number, and that is 2 less than the third. So if I had the third and then subtracted 2, that would be 2 less than the third number. And that's what it says is equal to that. Okay, that looks good. I think we're good there. So there's my second equation. I need one more equation. Let's see. It says the third is the second minus 3 times the first. So the third is, and then it gives me a bunch of stuff. So I'm thinking the third is, in other words, they're saying the third is equal to, right? That's another thing you could do with these types of problems. When they say the third is, you can kind of in your head think the third is equal to.
Mm-hmm.
The third is equal to, okay, so already the third is equal to what? It says the second minus 3 times the first. So what is that? The second minus 3 times the first.
Z equals y minus 3x.
There you go. The second minus 3 times the first. And I love having this written down somewhere. I don't do it every time. And especially in this case where they just say numbers, I might just skip this step. But having this written somewhere on your page might really help you out if problems get more difficult and more involved. It's nice to be able to just look back and go, yeah, okay, the second is y. Yes, the first is x. I feel good about this. Now, the only problem is these are not in standard form. And I'm sorry, we're going to have to change y. I said, let's call y equals mx plus b standard form, right?
Mm-hmm.
I like that. The book says no, standard form is something like this: ax plus by equals c.
Yeah.
Ax plus by plus cz equals d. In other words, all the variables are on one side and all the constants are on the other side. They call this standard form. So that's what we're going to call standard form. I'm sorry. I really liked calling y equals mx b the standard form, because that's standard. That's like, let's call it the canonical form from now on. So y equals mx plus b will be the canonical form of the line. Okay, so we need to get these 3 equations into standard form in order to finish up my system here. So let's do that. What do I do to this one to turn it into standard form?
Hold on. You subtract z from the other side,
Yeah, I'm gonna
or
bring
from both sides, I guess.
Yeah. I like to think about it as moving him to the other side, right?
Mhm.
So if he's positive on this side, he's got to be negative on the other side. So altogether, what's that going to give me on the left-hand side?
2x minus y minus z equals -2.
2x minus y minus z is equal to -2. Okay. What about this guy? Another thing I could do, and this is I'm going to be a little bit tricky here, is I'm just going to rewrite this side and think, what's more work? Bringing two things over to that side or bringing one thing over to this side?
One thing.
Let's move one thing. And so I'm moving the z. What do I have all together once I move that z?
Negative 3x plus y minus z equals 0.
Is equal to 0. There you go. There you go. And so, and that's another thing, right? Like, kind of keep that in mind, especially we're going to work a lot with lines and with, we're going to be moving into polynomials soon. You don't like, it doesn't have to be the literally on the left side, because we know, like, you know, once you have an equality, you can write it in either way that you want. And for calculation purposes, it just kind of makes more sense to say, well, right here, why don't I just move z to that side instead of moving two things to that side? But whatever, right? So right now we have minus 3x plus y minus z. So minus 3x plus y minus z is equal to 0. And now I have my system. So I'm going to get rid of the work we've done. I have three unknowns. I need three equations. I have three equations. I've lined them up in the right way, all the x's, all the y's, all the z's. And so I'm going to rewrite this as a matrix. And what's my first row going to be?
1, 1, 1, 26.
Second row.
2, negative 1, negative 1, negative 2.
Okay, last row.
Negative 3, 1, negative 1, 0.
Perfect, right? And now we're back into the realm of problems we've seen before. For right now, I do want to make sure we get through, because we're already 30 minutes in. I want to make sure we get through at least setting these guys up, right? Because that's kind of the problem. Now you're back to stuff you've done before. And unless you really want to, in fact, yeah, this one I don't really want to go into because I did it last night. There's a lot of fractions involved and we're just going to waste a bunch of time. But yeah, so maybe if we have enough time left over, then we might come back and do something. Right now, this is the setup. You would row reduce this bad boy to give you a, this is, by the way, called the main diagonal right there. And it's a diagonal. You can draw a lot of diagonals here, but that's the main diagonal. And you'll get that into this form right here. And you'll say, in this case, in the end, you'll say, oh, it's X, Y, and Z, not A, B, C, not P, Q, R. In this case, yeah, you'll say finally X is equal to A, Y is equal to B, and C is equal to Z. And that will be your answer. So, okay, moving on. Okay. Problem number 6. And again, I'm going to kind of talk through what goes through my brain as I read this stuff. So for number 6, it says in triangle PQR. So immediately what goes through my head is there's a triangle floating out here somewhere. It looks like that. And it has angles. That's how they describe a triangle. Whenever they say a triangle PQR, they mean, okay, those are the names of the angles. Well, those are the names we're giving to the angles, and P is equal to the number of degrees of that angle. And you'll notice right now, I haven't, with this picture that I've drawn, I haven't bothered to look ahead and say, oh, it tells me that Q is twice as big as R, and so I had better make Q bigger than R. No, we're not worried about that right now, because really, we're not interested in drawing an accurate picture or anything like that. I'm just thinking, okay, I have some triangle PQR. Okay. Now, it says the measure of angle Q is 3 times the measure of angle P. How do I write that?
Q equals 3p.
Cool. I like it. The measure of angle Q, whatever number that is 3 times the measure of angle P. Perfect. Okay. Now it says the measure of angle R is 30 degrees greater than the measure of angle P. What's my equation for that?
R equals p plus 30.
R equals P plus 30. Now I'm going to stop and say, wait a second. So that means that R is 30 bigger than P. Is that what they said? R is 30 greater than the measure of angle P. Perfect. Yes, exactly. Okay. And that's all they give me. How many unknowns do I have?
3.
How many equations do I need?
3.
How many equations do I have?
2.
So I need one more equation. And they don't bother to give it to me. It's there. It's in hiding. What is one more equation we could get from this? And if you can't think of it, that's cool because it's part of it.
Well, p equals r minus 30. No, wait, no.
If you tried that, like that would be true, right? And what we're going to find on what's today? Is today Monday? What we're going to find on Wednesday is that you will get what's called a dependent system if you do that. Like we could say, well, why don't I multiply one of these by 2? And then I can have like 2q equals 6p. And you could try that and you put it into your system, but it's not going to get you any closer to an answer. What we need is a unique equation. And this is one of the reasons I kind of wanted to do the dependent and independent systems before doing word problems, but the word problems they give you are all consistent systems. So this is the key here, is we're just going to have to use a fact about triangles. How many degrees, do you know this fact about triangles, that the interior angles always add up to something?
Isn't that 180?
180, right? And so that's what they don't tell you. It's there by telling you that it's a triangle. It's implicit in the question, right?
Uh-huh.
But they don't bother to like spell it out for you. But it's true that if you were to add up all those angles, they equal 180. So what's my third equation?
Q plus r plus p equals 180.
P, Q, R equals 180. And now what we need to do is say, okay, I'm given 3 variables. I want to establish an order because I know ultimately I'm going to put these in a matrix and the order of the columns matter, right? And so I like to say, well, why don't we just go in alphabetical order? P, Q, R, I believe is the alphabetical order. And so that's how I'm going to start here. I'm going to say, okay, my first equation, P plus Q plus R equals 180. Okay, what should my next equation be?
Q equals 3p.
Okay, so Q equals 3p. How do we put that into standard form?
Three p minus q equals 0.
Oh, I like it. 3p minus q equals 0. And I think when I did this, I brought him over to that side and I had minus 3p plus q equals 0. Guess what? They're the same equation, right? Like, because we know we could take any of these and multiply them by any number and it remains the same system. If I multiply this guy by -1, I get that guy. Ditto. If I multiply this guy by -1, I get that guy. So it doesn't matter which order you go in doing it, right? As long as this is true. So I'm going to go ahead and write this. 3p minus q equals 0. Okay, there's my second one. And I would recommend, as you're setting these up, actually write out the variables like this, like just like how I'm doing, because that's going to help you. Yeah. Okay. So the last equation, how do we write that guy?
Not entirely sure.
Okay, cool. So I'm looking at this and I'm thinking, and basically what goes through my mind is get all variables on one side and all the constants on the other side. And now I'm just kind of thinking about rearranging this equation. I could think, well, there's a couple ways we could do that. I could either bring this constant over here, in which case, bring this variable over here, in which case I'll have to take that constant over there.
Oh,
Or I could just move this one guy over to there and keep that guy there. And I think that's what I'm going to do. I'm going to say, all right, taking my P over to that side would give me a negative P plus R equals positive 30. Okay, so now watch how I'm going to do this guy. And so remember, so now you're going to end up with a bunch of stuff like this. And remember, the name of the game is get all the variables, the stuff involving variables on one side, get everybody else on the other. And that in these cases is all in terms of addition and subtraction. So now I'm going to take this guy and say, all right, I'm going to write him here. And I'm going to go minus P, oops, that's an R, minus P plus R. So minus P, I'm not going to do my plus R here because that's the Q column, right? The whole reason I'm doing this in the first place is to really help me out so that I could get an idea of what my matrix is going to look like when I go to set it up. And so this step that I'm taking right here is really just for my benefit, just so that when I write my matrix, a lot of the guesswork will be done. I'm going to double check that I have my P's in one column, all my Q's in one column, all my R's in one column. That is the order I want to go in, so we're good to go. I have all of my constants on one side. Now, you tell me what my rows of my matrix are going to be. What's the first row?
1, 1, 1, 180.
180. What about my second one?
3, negative 1, 0, 0.
3, negative 1, 0, 0. And what about my last one?
Negative 1, 0, 1, 30.
And now we're into our brainless, mindless, just plug and play, right? Easy enough. I wanted to look at that. I think this, yeah, I screwed this one up like twice because I don't remember what exactly I did. Like when I went to solve it, I think I did something. Oh, that's what it was. Okay, yeah. So I went and said, okay, I need a column of zeros, right? Just like you've been doing 1,000 times. I need a column of zeros right here. So I need to turn that thing into a negative 3. And I said, okay, negative 3. Negative 3, but only when I wrote it out. And negative 3 times 180 is like a minus 540, I think. But when I did it, and this is the thing, I screwed up and didn't write the negative. In my head, I said it's negative. And then I just went and added them together and then got all the way to the end. And I got that one of the angles was negative. And it took me forever to figure out what I did wrong. And like, it wasn't until I even started the problem over again, got the right answer, and was like, well, what did I do with this other case? And then I saw finally that I just didn't put a negative. So if you do something like that, I totally understand, right? Like
I did problem 7, I think 6 or 7 times. It took me like an hour, and I did it the same way every single gosh dang time.
Yep.
And I was like, what the heck? And I was ending up with the same exact answer that was completely wrong. I had like these crazy fractions. I was like, okay, what on earth? And I finally figured out that I wasn't multiplying something by -4, and I just like had it, I kept the same number, but I should have multiplied it. But I only forgot to not multiply that number in the row, but I multiplied all the other numbers in the row. I don't know.
Yeah, and that's the thing. Like that is part of this, right? Like that will happen. And again, if you do that on a quiz or whatever, I understand because I do it too, clearly, right? So, okay, let's just move on. I'm gonna finish up these examples. This guy right there, that is the system that you're gonna turn into the reduced row echelon form, back substitute, and you should get the answer. Okay. All right, so what are the other ones we're gonna to look at? 10. Okay, 10. 10. All right. Number 10. Says Pat picked strawberries on 3 days. I'm thinking, okay, sounds familiar. There's 3 somethings. He picked a total of 87 quarts. Okay. On Tuesday, he picked 15 quarts more than on Monday. Okay, now we're relating days together. On Wednesday, he picked 3 quarts fewer than on Tuesday. Okay, so now we have Monday, Tuesday, and Wednesday involved. Okay, so how many quarts did he pick each day? Okay, so they are asking me about these 3 days. And what I'm going to do now is say, well, we need to find out that, and this is the key here. Like, this will help you. It seems so trivial, like to write this down. But trust me, as you go on, things are going to get so much more complicated. And it will be really nice to have somewhere on your paper so that you could see it. I'm going to name these things. What do you want to name these 3 days? What names do you want to give for these 3 days?
Probably M, T, and W.
TW, right? So I'm going to say M, T, W. But this is the trick. Those aren't the days. I'm not solving for days. Days don't have a quantity, right? It says how many quarts did he pick each day? So what I'm going to do is say M is equal to the number of quarts he picked on Monday. Tuesday is equal to the number of quarts he picked on Tuesday. And Wednesday is equal to the number of quarts he picked on Wednesday. And for these problems you're going to have in your homework, this seems so trivial. You're like, I know what we're talking about. Why would I need it? Trust me, when you start doing like multiple systems and you have like, especially in chemistry, this kind of stuff shows up in chemistry all the time, not necessarily as systems of equations, but where you've done like 2 pages of work and then you have an answer, you're like, oh, I have X. What was X? Oh no. Oh no. And so like just to have it somewhere, you could go, okay, that's what we're doing. Okay, so let's break this thing up. It says he picked a total of 87 quarts. What equation can I write involving M, T, and W and this little bit of information?
M plus T plus W equals 87.
I like it. M plus T plus W equals 87. And I'm going to stop and think and say, okay, if M is, and this is what's nice, M is the number of quarts he picked on Monday. T is the number of quarts he picked on Tuesday. W is the number of quarts that he picked on Wednesday. That altogether, just by given the problem, should be 87 because it said he picked strawberries on 3 days and he picked a total of 87. Okay, we're good. Now it says on Tuesday, he picked 15 quarts more than on Monday. How do we write that as an equation? Say it again. On Tuesday, picked 15 quarts more than on Monday.
So T equals M plus 15.
Plus 15. Let's see. So the number of quarts he picked on Tuesday was equal to the number of quarts he picked on Monday and an additional 15. Yeah, that's what that just said, right? And like I like to, once I write it down, I like to say it in a little bit different way in my head so that I could just double check and go, yeah, that was that. And it says he picked 15 more quarts on Tuesday. He picked 15 more quarts than on Monday. Yes. Okay. So that's my second equation. We're going to need, we have 3 unknowns. We need 3 equations. I have 2 equations. I better get one more. And so it says on Wednesday, he picked 3 quarts fewer than on Tuesday. So what's that?
W equals T minus 3.
I think so, because on Tuesday he picked more. 3 less than what he did on Tuesday was what he got on Wednesday. And yeah, on Wednesday he picked 3 quarts fewer than on Tuesday. So if we knew how much he picked on Tuesday, we would take 3 off of that total amount and we would have the number that he did on Wednesday. Okay, that looks good. Okay, so I've already implicitly written an order, and it makes sense to go Monday, Tuesday, Wednesday in that order. So let's turn this equation into standard form. What do I need to write over here?
T minus M equals 15, or negative M plus T equals 15.
There you go. Negative M plus T equals 15. Yep, exactly, right? And you're right that it is T minus M equals 15. That's exactly the same thing as that. But it's like, well, now I know that I want it written in a certain order. And so you already knocked that out. Good to go. What about my last equation?
Negative T plus W equals negative 3.
And what's going through my head is I visualize this T flying over to this side. And when I see that, it's like, yep, he's going to pick up a negative by going over to the opposite side. The W is still just a positive W, and he will equal a negative 3. Now, I'm going to double check. My M's are in line. My T's are in a column. My W's are in a column. All of my constants are on that side. And so I'm good to go. What is my system going to be? First row.
1, 1, 1, 87.
Yes. What about my second row?
Negative 1, 1, 0, 15.
And my final row.
0, negative 1, 1, negative 3.
Perfect. That is the system. We would solve that guy. Now, is this the one I wanted to talk about? Yeah, and I think actually, so I briefly looked over your homework and it looked like you had already picked up on this, like, because at any time we could flip these guys around, right? And I know that this guy already has a 1 in this. It would be nice if this guy ended up right here. And so my next step might be, and I also, of course, I know I need to get a 1 here, or I'm sorry, a 0 right here. And so as I go to do this one, I might think something like, well, this row isn't changing, the top row isn't changing. I know that when I add that to that guy, that's going to go away, but then I'm kind of anticipating, it's like, that's going to give me a 2, but that guy's already going to be a 1. Right? I don't need to get a 0 there. So I might just go ahead and say, well, if I move this guy up to here, oh, and I could kill 2 birds with 1 stone by saying, well, he's a negative. I could just go ahead and make him positive, make him negative, make him positive. And so I'm kind of killing 2 birds with 1 stone in that one maneuver. You don't need to do that. It's just like, after you've done about 20 of these, you can anticipate 2 steps ahead and go, I see what's going to happen, right? And so I might, as I'm doing that, just start off like this. And what I'm telling you is, the reason I'm bringing it up is, if you do something like that without explicitly stating what you're doing, I'll know what you're doing and I get it. So you don't have to worry about being super precise. What you do have to worry about is doing it wrong, right? And that's one of the nice things about going just step by step and then like writing out all of the numbers that you're adding to everything, so that really for you, that you don't mess it up. So if you don't want to skip a couple steps and make this little change, that don't do it, because if you know you're going to if you know you might screw it up, you probably don't want to in the first place. But if you're so comfortable with it after you've done 1,000 of these and you're like, I know where this is going, I know I could just do this, just do it, and that's fine. I'll understand. So, okay, long story short, in the end, we're going to turn this into a row, or the main diagonal of ones, zeros everywhere else. And then for our final answer, we will say not x equals y equals z equals, we will do something like this, m equals this and this. And what's nice also, and this is just in general, is if you're given a problem like this, like they haven't defined variables for you, right? They didn't say like in the previous ones, they say P, Q, and R equal this and that. Like they said, the angle, so like in the previous one we did, it said in triangle PQR, the angle Q. So Q is an angle. They've told you what that is. In this case, they didn't say what any variables are. And so technically, like we should somewhere write this down so that everybody's on the same page, so that I know that when you write M, you don't think that Monday is equal to a number, so that we both know that what you mean by M is the number of quarts that was picked on Monday. And you don't have to be pedantic about it. Like this right here is the number of quarts on Monday in the context of the problem. That's perfectly good. Because then in the end, when you write this down, which it comes out to be 20, 35, and 32 is the answer. When you come to get this and you write that and go there, then there's no question that what you mean by this is that 20 is the number of quarts that was picked on that day, right? Whereas if you didn't write any of this down and you just wrote that, of course I'll know what you mean, and of course anybody will know what you mean. But as stuff gets more complicated, it's a really good habit to get into so that somebody grading your paper knows exactly what you mean. So I'm just being pedantic on that, but okay, so we have 5 minutes and I want to get into one more question. So these are the types of questions you're going to see on your homework. Yeah, and the other ones that we haven't talked about, they should be pretty obvious how to set up. Like it's all pretty much the same game with each one of those. There's a certain kind of problem I love involving this, and I'm just going to go ahead and give it to you. I think something similar was given in a previous chapter. They used it as an example in a previous chapter. But this is the kind of question I love, and you might see something like this in your future. So here's the question. Chemist needs 500 milliliters of 5, did I do 5? Yep, 5% acid. And has a solution of 3% acid and one of, I think I used 8% acid. That's ugly. 8% acid. If this were a chemistry problem, I would say something like,
oh, I had one of these chemistry problems last year.
Yeah, there you go, right? So I would say something like perchloric acid or something. Chemistry problem. We're just going to say it's some kind of acid of some certain concentration. Now, the question is, how much? It sounds like you've heard this before, and it was something very similar is already in your book, right? How much of each solution should they use? Okay. So what we need are variables, right? And I'm going to say, well, about my two, and it looks like, right, this sounds like two unknown variables because, right, we need that much of that much acid. Okay, give me a second. And we have a solution of that much acid. So right now what's going through my head is this. We have, and it's implied that we have an unlimited amount of each, right? Like there's no constraints. That's what they're called. There's no constraint on the amount of acid we could use. You got to assume, okay, well, if you have a solution of that and a solution of that, you probably have way more than you need. And so we have some 3% acid, we have some 8% acid. And I like doing this. I like to actually draw out a little beaker with a little line of liquid. And I like to write what it is because this helps me visualize what's going on. And so I imagine I'm going to take some amount of this, and put it into a new beaker. And what I need to get out is a total of 500 milliliters. And so what I'm going to do now, then the question is, how much of this should I use? How much of that should I use? So I'm going to give those variables. I'm going to give those, they're variables because we don't know how much. Let me give them names. I say X is the amount that I'm going to take out of the 3%. Y is the amount that I'm going to take out of the 8%. Now I'm going to go ahead and write that down. Like I said, I want to define my variables, right? When it's not given in the problem, like it is with triangle PQR, I'm going to go ahead and actually write them out and say, okay, then X is the number of milliliters of the 3% acid to use. Y is going to be the number of milliliters of 8% acid that we use. Now I have that written on the page. That's going to help me out. This will be really important, especially like in chemistry. Then they'll say something like, how many ounces of acid should this be? And it's nice to know, okay, well, the thing I'm doing right now is milliliters. Okay, and so then in the end, I know that X will be something in milliliters. Then I'll convert that to ounces at the end, whatever. Okay, so we've got this right. So what equation can I use? Give me an equation that we have thus far with this information.
X plus Y equals 500.
Exactly, right? Because I'm thinking, okay, some amount of this came from X. In other words, you have X milliliters from the top one. You have Y milliliters from the bottom. And together, when you add them up, you've got to get 500. So that gives me my first equation. I'm going to say X plus Y equals 500. Okay. Now, we have two unknowns, so we need how many equations?
There are two.
How many equations do we have?
One.
So we need one more equation. Can you think of another equation that we could write with this? This is difficult. This is real difficult. So one thing we're going to think about is this, and I'm going to think, so we know the total number of milliliters. We also know that some percent of this thing, in fact, 5% of this is just pure acid. We also know from our original guys, from the 3% acid, right? Whatever that was, this was the 3% acid. So whenever I take the X amount of it, 3% of it, whatever X is acid, because, well, only 3% of this stuff is acid. That is 3% of the total is pure acid. Ditto with the other thing. If we had our, and I like picture thinking here. That's why I'm doing all this, because this is what goes through my brain. It's like, well, you have some beaker of 8% acid. That means that you have this big volume of acid, but only 8% of it. The bottom, we'll just think of it as the bottom 8% of it is acid. It's pure acid. And so in the end, also, we know that whatever this is, we're going to think about it as the bottom 5%. That's not how you spell acid. Okay, so some percent of it is acid. So now we could say, well, now we could relate. So before we were talking that we had an equation involving milliliters. Now let's get an equation involving acid. So how many milliliters of this is just acid? How do I do that?
Do the percent thing, 5% of 500, right?
How do we, there you go, exactly. How do we compute 5% of 500? We multiply by something.
0.5?
0.5 or?
No, 0.05.
0.05. So what was going through my brain is, wait, hold up, 5% means, if we want to go percent, we know that's 100, right? Divide by 100. So 5 parts per 100. So I move the decimal place twice. That's what goes through my brain right there. I see that, and then I imagine a little decimal bouncing over twice. And so we know, okay, yes, 0.05 times 500 is the total acid that we want. And so play the same kind of game here. We know that if we take X milliliters of that, we know that of those X milliliters we pulled out, only 3% of that is pure acid. So how do we do that numerically? If I wanted to say how much acid came from here? X milliliters of acid. What's 3% of that? I don't know the actual number, but in the same way that we calculated this, we say, well, you take whatever the volume is.
0.03 times X.
0.03 times X is acid. There you go. So in other words, 3% of that, whatever that volume is, I'm imagining like I take 2 liters out. Well, how much of that I just took out to put into here was actual acid? Well, whatever you did, however many milliliters you took out, multiply that by 0.03, and that's what you have. Ditto right here. How much of that I've taken out is acid? I took out a total of Y milliliters, and so 8% of that can be written as
0.08 times Y.
There you go. And so now all this has to add up. This is why I like drawing pictures too, because now I'm imagining, well, if I took that much, if from what I took from that much of it is acid, and of what I took that Y amount, that much of it is acid, then it has to add up to that total amount of acid. That's where this is coming from, right? So finally, right, my second equation should be this much acid plus this much acid equals this much acid. All together, then, I'm going to get 0.03x plus 0.08y is equal to, now I'm going to do some erasing here. 0.03x, 0.08y is 0.05 times 500. Okay, so we have a system, two equations, two unknowns. We're going to talk about this Wednesday, but one equation is not a multiple of the other. So we do in fact have unique equations, which are going to help us. But okay, so now here's the thing. There's two ways we could go about doing this. The first way is to just blindly say, okay, well, there's my system, right? I could just write it in matrix form with a 1, a 1, and a 500. 1, 1, 500. 0.03, 0.08, and then 0.05. We could calculate that out, I guess, but we'll just keep it like this. 0.05 times 500. And if we started there, right, there's one more step we could take that will make our lives much, much easier. Or we could just brute force and say, and if you want to brute force and just go for it, that's fine. You'll get the right answer. We could say, okay, I guess I need a negative 0.03 there. So I'll multiply that whole thing by negative 0.03. And then I'm adding a bunch of, but honestly, I hate working with decimals. And what I would do, in fact, I would do this before I even wrote my system, but what we could say is, you can multiply through by any constant at any time, right? Like I could multiply this entire thing by 2 and we have the same system, right? It's the same two lines because really, right? That's a line, right? That's y equals negative x plus 500, which looks something like that. This is something else, it's some other line. And the thing is, like, I can multiply that entire line by any number and it's the same line. Same thing if you have 3 unknowns or 4 unknowns or 5 unknowns, you can multiply the entire thing through and it stays the exact same line that you begin with. Since that's the case, I could say, well, how do I turn that? That's a decimal. What do I need to multiply it by to turn it into an integer?
Um, 10.
I'm trying to move that decimal place over. That's my goal, right? It's like when I look at that, I think, uh-oh, decimals. My life would be a lot easier if this decimal moved 2 places to the right.
So you multiply by 100.
If I multiplied it by 100, or you could think about that as multiply it by 10, it moves over once, multiply it by 10 one more time, and it moves over twice. So we could think about it like that. We could say, well, multiply this guy by 10 twice, or multiply by 100, and that's going to have the effect of moving this guy over. In each case, each one of these decimals will move over 2 places. And then my new system will be, let's see, 1, 1, 500. Moving that guy over twice gives me a 3. Moving that guy over twice gives me an 8. Moving that guy over twice gives me a 5 times 500. And now I'm just going to go ahead and say, oh, wait, 5 times 500. That's something I could wrap my head around. That 0.05 times 500. I don't even want to think about what that looks like, right? But 5 times 500, that ain't so bad because I could just do this and say, well, multiply those guys together, we get a 0, a 0, and a 25. So that's just 2,500. And so now I have my system. 1, 1, 500. 3, 8, 2,500. And this ain't so bad. Now I can see, okay, multiply the top by a -3, that gives me -3, -3, negative 1,500. Add that to that. We've already got stuff and we just keep going and it ain't so bad. So that's one thing, right? And I said that's if I were to just set this up blindly, right? And just say, well, there's my system, write it in a matrix. And then I would say, if your system begins with, if you're given a system with decimals in it, then our new first step is clear the decimals. Then that's always going to be the case, right? Or we could have done that before we even put it into a system, right? And that's probably what I would do. Given something like this, from the very beginning, if I had a system like this, right? They say solve the system, right? Solve for X and solve for Y. My first step would be, well, let's look at this. We have a 1 and a 1 and a 500. We have a point, I have decimals. I could kill all of these decimals by multiplying both sides. Or we could just think about it as, if I move this decimal over 2 times, and I'd have to move that one over 2 times and move that one over 2 times. So I would just begin by writing it this way. Move the decimal, move the decimal, move the decimal. And there you go. And so if you want to do that, that's fine, as long as you know what you're doing. But my whole point with this example, well, one is to, so you see this, because you might see that in the future. But also because it's real important to know that, like, don't make this harder than it needs to be, right? Like, we want to turn problems we haven't seen before into problems we've seen before. And decimals just ruin your life, so just get rid of them. We can get rid of them at will. Ditto with something like this. A decimal is a fancy way of writing a fraction. In fact, 0.03 means the same thing as 3 divided by 100. So if I had a system, let's say it looks something like this. 3/7 x plus 2/14 y equals 3. And, I don't know, how about 1/2 x minus about 3/8 y equals 5. I could say, man, I hate fractions. I really hate fractions. Instead of starting like this, like putting this into my system, let me kill those fractions. So that's what I'm going to do. I'm just going to kill these fractions. And when I look at this, I think, well, this top one here, go ahead and multiply this by anything I want. If I multiply by 7, that'll kill that fraction, but it won't kill that one. But I notice that if I multiply by 14, that'll actually kill both of them. So that's what I'm going to do. I'm just going to kill this fraction by doing this right here. This guy jumps over the 7, leaves me a 2. And so we end up with, I'll just rewrite this over here. And this is, I'm blowing through this because we're out of time and I just want to finish this up. But this is what goes through my head. I have a 14 divided by a 7 leaves me a 2 in the numerator. 2 times 3 is 6. Okay, the 14 jumps over, kills the 14. He's gone. That's nice. 2 times y. I know whatever 3 times 14, I guess I'll do it. 14 times 3 is 12, and 3 and 42. Okay, so 42 right there. Now this guy, I'm kind of thinking the same thing. If I multiply by a 2, it kills him, but it won't kill him. 3 is not going to work. Oh, an 8 will work. If I multiply everybody through by an 8, then the 8 comes over, gets divided by 2, leaves me a 4, so we have 4x. 8 jumps over, gets killed by the 8, and leaves me with nothing but a 3 in the top. And then 5 times 8, I think, is a 40, something like that. And so if I were, what I'm getting at is, if you're starting off with a system with fractions in it or with decimals in it, go ahead and get rid of them before you even start. It'll make your life much easier. And that's, yeah. Does that make sense?
Yes.
All right. I think that's it for today. Now, let me give you your homework. Let me write this up. All right. And yeah, and this isn't too bad. It's the hard part is just translating this out of math speak and getting it into a system. So this is chapter 4, section 5. Chapter 4, section 5 exercises. We want to do, let's do. Yes, I want to do 1 through. Ugh, I guess we'll do that one. Yeah, okay. I'm sorry. 15 is, I don't like it, but it's good. So 1 through 15 odd. And do we want to do that one? Ugh, no, that one's ugly. And 18. 1 through 15 odd. And 18. So that's not even 10 problems. That's
Okay.
good. And again, like especially the first ones, they're ones involving just like the very first thing we started with was this, the sum of some numbers is this, and then it gives you some little bits, and that's so straightforward. There are a couple triangle problems in there. And the other ones, like Pat picks strawberries. We did that one. The rest of them are pretty much like that. And then 18 is challenging, and there are decimals involved. And the cool thing about decimals is that you could get rid of them to start with, right? Just a word of note, like you're going to end up with something like this. And it's like, I think it's like 3 equals some number. You could really go overboard here and say, well, there's 2 things. So I need to move this over 2 places. And I need to move this over 2 places. And then whatever number that is, which is already a big number, you'll have to move that over 2 places to make it big. In other words, you're multiplying by 100. And then that's going to make the number that's over here way big. But you've gone a little bit overboard, right? We don't really need to move this guy 2 places because in both cases, that's just a 0. Like, we don't want to overkill, right? Just like I know in this case, I could kill both those fractions with a 16. But I don't need to go all the way to 16 to do it. 8 is good enough. Just like, so that's kind of what's going on here. Yeah, you have a 5.50, but you don't even need to write the 0 in that case. So if you did go overkill and you did it consistently and you moved it 2 places or 5 places or 10 places, you'd end up with the right answer. It's just your numbers are going to get ridiculously big and it's going to be harder to deal with. But there you go. I think that's it. Any questions before we finish up?
No questions. I don't think I have any questions.
So you're feeling good with working with the matrices? It looks like, I didn't go over it like your homework in detail, but it looks like you got the idea.
I actually really enjoy them, which is shocking because I've never enjoyed math before. So
Cool. And I was saying, I think last time I said it's like Sudoku, and you didn't know what Sudoku was. It's like a number puzzle, and that's how I think of it. It's like a number puzzle. It's like I'm trying to turn this picture into this picture, and it's fun. So.
Yeah, it's fun.
Cool. I'm real glad to hear. Well, you got more work, some more examples to mess with. So
okay.